All right, so we have gone through an overview of cost benefit analysis. Now we're going to get into the meat and bones of cost benefit analysis, and now how are we actually going to do it? And a big part of that is going to be discounting. So, what is discounting? Well, our projects, our programs, things we want to institute in our organizations, they're going to have costs that happen up front. We're going to need to infuse large amounts of money up front, and then we're going to have our benefits from that program happen later down the road, whether it's 1 year, 2 year, 5 years, 7 year. But we're going to have these costs up front and benefits on the back end. So we need to discount um, our costs and our benefits, um, and put everything on a level playing field. So what we do is through discounting is take our current dollars that we are spending and compare them to future dollars that we are benefiting from. Why would we do this? Well, think about it. A dollar today has a different value than a dollar tomorrow. So I can take a dollar today and buy a candy bar, or I can take a dollar today and invest it, and in 5 years I have extra money from that investment. So um, comparing a dollar today to a dollar 5 years from now, it's going to be very different. So we're putting everything on a level playing field, and then we're taking this natural risk averse nature that we tend to fall into. And we want to spend money on a program right now. We're risk averse. We could just take that money and invest it instead. So why would we spend it on this program? What benefits are we going to gain from this program? And so we're going to discount it, and we are going to compare a dollar right now in my hand to a dollar 5 years from now in my hand. Another way to put this is I've got someone, let's call him George. George can buy a bond right now. In 1 year, that bond will give him $1. So he's got a bond. He spent some money on a bond, and in a year, he gets $1. So how much money right now is he willing to pay for that bond? Because he can pay for that bond and get $1 in 1 year, or he can not buy that bond and just hold on to that amount of money. So whatever that amount of money is, which is the greater the benefit to George. So he can purchase something now, or he can hang on to it, and that's really what we're getting at with our cost benefit analysis when we throw in discounting. And we are always going to discount in our cost benefit analysis because I can spend money on this project, on this program right now, or I can hold on to my money, however much money that is. Which one is going to give me the greatest monetary benefit? Is it going to be spending the money, or is it going to be holding on to the money? So we said that George can always hold on to his money. I can either spend it, or George can spend it, or George can hold on to it. So if George spends it, he spends it on that program. If he holds on to it, he has the option of earning an interest rate on it. So we all have checking accounts, savings accounts, maybe 401ks, whatever your investments are. We have money out there that is earning interest. We're not doing anything with it. We're not spending it. We're earning interest. So we have the option to spend it, or we have the option to earn an interest rate on it. So which one do we do? And that's what the cost benefit analysis and this discounting really gets to, is which option do we pick? Do I spend it, or do I save it? So we're looking at the present value of future money, and we've hit this formula before. We'll go over it again. The present value of $1 there. So x1 in that formula is the present value of future money. So x1 is the present value of money I might have some time period in the future. My $1 is up there in the numerator. I've got a 1 up in the numerator. That's my $1. So 1 year from today, I've got some amount of money. So that 1 plus R, that R is our interest rate that we might, or my discount rate. So interest rate, discount rate are interchangeable. So what is my interest rate? What is my discount rate? That is R. So 1 plus R, let's say it's 5%, that's 0.05 is my rate. So 1 plus R would be 1.05 with a 5% discount rate. So I can figure out what the future value of my dollar is right now, 1 year into the future. But how do I figure out what that rate is, what that R discount rate is? So, I've showed you the constant dollar calculators before, so we can go to those and figure out an interest rate or a discount rate. We can look at our inflation rates, our national inflation rates over a given amount of time. That'll give us some discounting rates. A 5% discount rate is pretty standard. If you're a government agency, it's going to be a little bit lower because you can borrow money at a lower interest rate. Maybe a 2%, 3% rate for a county service might be more realistic. A higher rate, maybe a 7 or 8%, maybe more realistic for a for-profit organization. So our discount rates are going to be a little bit different, and that's where our sensitivity analyses come in. We're going to play around with these discount rates a little bit when we're doing cost-benefit analysis. So let's really get into it with a cost-benefit analysis using discounting. And you've got an assignment due for this week that is a cost-benefit analysis assignment, and this is what I'm really looking for and how you should be setting this up. You should be discounting and calculating it this way. So I've got a table here set up for you. On the top here, I've got some time periods. So we've got year zero. Year zero is just your startup costs. So you're always going to have some startup costs. You always have to invest in a program, in a project, and you're investing in this program project without any benefits. So always going to have costs. Here we have $50,000 worth of costs. We have no benefits because we're just investing in this program. Our net benefits are going to be our benefits minus our costs. So here we have a negative $50,000 net benefit because we have no benefits. We're just investing in this program, whatever it may be. And then we are discounting right here. So I have my dollar amount on the numerator, and in the denominator I've got my 1 plus my discount rate, or my interest rate, which is 5% in this case, and that is raised to the power of the time period. And in this case, the time period is 0. I am just starting to invest. My time period is 0. Anything raised to the power of 0 is 1. So there at the bottom, I've got a net benefit at 5%, 5% interest rate, 5% discount rate of negative $50,000. So that's in time period 0. This is my initial investment in my program, in my project. Now I have time periods 1, 2, 3, and 4. These are at the end of year 1, end of year 2, end of year 3, end of year 4. So I've got my initial investment. We will always have a year 0. That's my initial investment. And then at the end of year 1, and then going on forward, and you can go forward a few years, you can go forward 5 years, 6 years, 15 years, however many years you want, as long as you can somewhat accurately estimate the cost and the benefits. So we're going to start here in year 0. I have 0 benefits because the program is not up and running yet. I have $50,000 in costs because that's my initial investment. My net benefits, my benefits minus my costs, are a negative $50,000. My net benefits at a 5% discount rate, negative $50,000, over my 1 plus my rate, which is 5%, raised to the power of my time period, which is 0. That equals 1 in the denominator, so I just get negative $50,000. We're going to move on to year 1. So now my initial investment is done, and now I have implemented this program. So I'm gaining some benefits. Whatever the benefit of this program is, I'm gaining $12,000 of benefits from this program. I have my initial investment of $50,000, but in year 1, now I just have kind of a maintenance cost of $2,000 per year. So my net benefits, remember benefits minus costs, is a positive $10,000. So in my year 0, my initial investment, I had a negative net benefit. Now we have a positive net benefit. We are going to discount that here, and it's still showing that formula for you. My net benefit at 5%. I've got my $10,000, my net benefit. 1 plus the discount rate, 5%, raised to the power of the time period, which is 1. So my net benefit was $10,000, but now my net benefit at a discount rate is about $9,500. So a little bit lower. So now we're going into the future. My time period 0 is the present day. Now I'm going 1 year into the future, and I am finding the future value of my present money being that of $10,000, my net benefits. That's my present money. I have to discount it, and that's my future value at a 5% discount rate, or a 5% interest rate. So I've got $9,500 in benefits in year 1. Now let's fill in the rest of this table for years 2, 3, and 4. My benefits go up from $12,000 to $22,000 for years 2 and 3, go back down to $12,000 for year 4. My carrying costs, my maintenance costs are $2,000 across the board. So then my net benefits, again benefits minus costs, $20,000, $20,000, and $10,000 for year 2, 3, and 4. We're going to do the same formula. I've got my net benefits over 1 plus the discount rate, which was 5%. So 0.05 raised to the power of the time period. So raised to the power of 2, raised to the power of 3, raised to the power of 4 for years 2, 3, and 4. So we're going further and further and further into the future, so we need to keep discounting. So my $10,000 in present value turned into $9,500. Here my $20,000 in present value turns into $18,000. My $20,000 turns into $17,000, and my $10,000 in year 4 turns into a little over $8,000. So we are taking our present value, our present net benefit value that we are estimating in this case. So this is a program that we're pitching to our let's say our county commissioners, and saying, okay, well, 4 years into the future, money is going to be worth a little bit less than it's worth now. It's going to have a little bit less buying power than it does now. So $10,000 right now is worth about $8,000 there in the future. So what is the future value of our money? Then the next step we're going to do is sum all of these values here at the bottom together, add all of these values together at the bottom, and say, over those 1, 2, 3, 4 years, is this going to be a benefit or is this going to be a cost? Because that's our cost benefit analysis. Are we in the positive or are we in the negative? And what we see is after year 4, sum of net benefits a little over $3,000. So we're in the black. This program will probably be approved because it's not losing money, even though we have discounted and taken into account the future value of all this money. But what if, as we see at the bottom here, what if our discounting rate wasn't 5%? What if it was 8%? So if we refill this table, all we changed was the discount rate. Went from, 0.05 to 0.08. So we went from a 5% discount rate to an 8% discount rate. So our future value of money, what if it were borrowing money to implement this program, to build this new station, to build this new building? And our interest rate goes from 5% to 8%. That's our discount rate, goes from 5% to 8%. What is our difference? So with our 5% discount rate, we have a net benefit of a positive $3,100. And then if we shoot to a 8% discount rate, now we're at a negative $369. So all of a sudden we are losing money over those 4 years. So our discount rates are very important. Our interest rates are very important. We need to know what we're borrowing at, what the inflation rates are at. So what are we expecting our discount rate to be? And that goes into our sensitivity analyses. So maybe I expected a 5% discount rate. Well, my sensitivity analysis now goes above and beyond to an 8% discount rate. Well, now we're in the negative. So if we go a little bit too high on that discount rate, on that interest rate, we might actually be in the negative, and this program might not be approved. So that is how to set up a simple cost-benefit analysis table and matrix with discounting, your discount rates, your interest rates. If you have any questions, comments, concerns, cuss words, please let us know.